Graphs, basic concepts. Basic concepts. Graphs, basic concepts. Graphs, basic concepts. Definition. 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 A graph written as a graph written as G V comma E. V is the vertex, E is the edge. Consists 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 consists. First one, a finite set of vertices V. A finite set of vertices V. Vertices V. Finite set of vertices V. Also called nodes. Also called nodes. Nodes. Nodes are points. Are points. Points. Second one. A finite set of edges E. A finite set of edges. A finite set of edges E. Edges E. Set of edges E. Finite set of edges E. Edges E. Edges also known as arcs or lines. And third one. A mapping F from the set of edges. A mapping F from the set of edges. And the set of edges. 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 E to the set of vertices. This E to the set of vertices. Set of vertices. Set of vertices. Set of vertices. Vertices. V such that small e belongs to capital E. Small e belongs to capital E. Is associated with a pair of elements. Is associated associated pair of elements, pair of elements, elements, pair of elements. Page number one time, pair of elements of V is called graph. Is called a graph. Called a graph. Next definition. EFN next definition. A multigraph G V comma E. A multigraph graph G V comma E. V comma E. V comma E. Consists of a set of V vertices. Consists of set of V of vertices. V of vertices. Vertices. V of vertices. V of vertices. And a mapping F from V. Here, mapping from V. F from V to V2. U comma V. U comma V. U comma V. Such that U comma V belongs to U comma V belongs to capital V. Capital V. The edge E1, E2 are called multiple. The edge E1 and E2 into E1 and E2 are called multiple or parallel edges of multiple or parallel edges. Parallel edges. Parallel edges. Parallel edges. Parallel. Parallel edges. F of E1 equal to F of E2. This is called multiple graph. Multiple graph. Yeah. An edge joining vertex. An edge. An edge. An edge. An edge. Joining a vertex to itself. Joining vertex to itself. Vertex to itself. itself is called loop. A text itself is called loop. How it will be a suppose rectangle. Vertex joining itself is a loop like that. Joining itself is a loop. Suppose joining itself is a loop. This is called loop. Next, here examples of graphs. Examples of graphs. Examples of graphs. Examples of graphs. So simple graph or undirected graph. Simple graph. Simple graph or undirected graph. V1, V2, V3, V4. This is known as simple graph. Simple graph. Simple graph. Second, directed graph. So this is undirected graph. Undirected graph. This is directed graph. Nothing but directions will be there. Direction. Directed. V1, V2, V3, V4. This is simple graph. Graph. Directed. Directed graph. Directed graph. Directed graph. Next, multigraph. 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 V1, V2, V3, V4. This is known as multigraph. 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 This is pseudograph. Pseudograph. So V1, V2, V3, V4. Be silent. Pseudograph. PSE U D O graph. GRAP. Pseudograph. So next. Next. Definitions. Definition. DEFN. Definition. 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 A vertex is said to be even or odd. A vertex is said to be even or odd, even or odd, even or odd, according to its degree, according its degree, according its degree, is an even or odd number, is an even 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 degree is an even or odd number, odd number, odd number, odd number, even or odd number. A vertex of degree is zero is called isolated vertex. A vertex a vertex of degree zero of degree zero, a vertex of degree zero, vertex of degree zero is called isolated vertex. Is called isolated isolated vertex. Isolated vertex. Isolated vertex. It follows that an isolated vertex is not adjacent to any vertex. A vertex is called pendant if and only if it has degree 1. A vertex is called pendant, 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 if and only if it has 1 degree, if and only 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 if it has degree 1. It has degree 1, degree 1. degree 1. It has degree 1. Next, theorem. Theorem is 10 marks. Theory. Discuss about theorem. Page number 114. Page number 114. In any graph G, if any graph G, in any graph G, in any graph, any graph G, the number of vertices of odd degree, the number of vertices, number of vertices of odd degree is always even. Odd degree, odd degree, odd degree, odd degree, odd degree is always even. Is always even. Even proof. Proof. Consider the equation. We consider the vertices with odd and we consider the vertices with odd and even degree. Even degree. Odd and even degree. In the graph G separately. Graph G. Separately. Separately. Or G separately. Separately. Then the quantity in the left side, then the quantity in the left side equation in LHS, left hand side equation, left hand side equation. What is that equation? Left hand side equation. 7.1 can be expressed equation and one can be expressed can be expressed as the sum of two sums, as the sum of two sums. Sum of two sums. Sum of two sums. Sum of two sums. Each taken over the vertices of even. Each taken. Each taken. Taken over the vertices. 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 Of even and odd degrees respectively. Of even and odd degree. Odd degree respectively. Odd degree respectively. Respectively. That means sigma. Here 7.1 equation means what is the 7.1 equation? Sigma I equal to 1 to n. I equal to 1 to n. Degree Vi. Degree Vi. That equal to 2e. This is called 7.1 equation. Equation 7.1. Okay. Next. That equal to sigma I equal to 1 to n. 1 to n. Degree Vi. Degree Vi. That equal to sigma even d of Vi means degree of Vi plus sigma odd. This is odd 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 d of Vk f Vk. Equation number 2 consider, or equation number 1 consider. Simple one is equation number 1. This is equation number 1. This is equation number 2. Okay. So LHS of 2 is an even number. LHS of 2 is even number. Even number. Even number. Even number. Even number. Expressions of RHS second to both even number. That implies sigma odd T of Vi, T of Vi, T of Vi equal to an even number, an even number, even number. Equation number 3. Equation number 3. Equation number 3. Since each dvi, since each dvi is odd in equation, is odd equation, odd equation. So about the third equation, the total of terms in the sum must be the total of sum must be must be must be sum must be sum must be even to make the sum, even to make the sum, make the sum, make the sum an even number, even number, even number. Hence the theorem. Hence the theorem. Hence proof. Hence proof. This is possible for 10 marks question. Okay. Next. Example someone. One problem for theory. 6 marks question. Example 1. Page number 115. 115. What is the largest possible n? What is the largest possible one? Possible one. Largest possible n. Largest possible n. The number of vertices in a graph. The number of vertices the number of vertices vertices in a graph. Number of vertices in a graph. 35 edges. 35 edges. 35 edges. and all vertices of graph and all vertices, all vertices, all vertices of degree at least 3. Yes, of degree at least 3 and at least 3. Uh, at least 3. Solution. Solution. Let n be the number of vertices in that graph. Let n be the number of uh, vertices in that graph. In that graph. Number of vertices in that graph. So we know that sum of degree of the vertices WKT means we know that sum of degrees of vertices, sum of degree, sum of degree of vertices, sum of degree of vertices is equal to 2 into 35. 2 into 35, that equal to 70. So since all vertices are of degree, since all vertices of degree all vertices of degree greater than or equal to 3, greater than or equal to 3. Sum of the degrees of vertices is greater than 3n. The sum of the degrees sum of the degrees of vertices greater than or equal to 3n, greater than or equal to 3n. Therefore, 70 greater than or equal to 3n. That implies n less than or equal to 70 by 3 less than 24. So the given graph can have at most 23 vertices. So the given graph can have at most can have at most No, 23 vertices. 23 vertices. This is important for 6 marks question. Next. One more. Discuss one more theorem. Page number 116. Theorem. For 10 marks. Theory. 10 marks theory. In any directed graph, any directed graph, any directed graph, G V comma E, G V comma E, where you are asking 23. So because 70 by 3 means 23 point something will be there. That is less than 24. No? Then second graph can at most 23, but says point look we won't show. Right? Not to 2. 23 that is. 23 vertices. 24 is less than 70 by 3 means 70 by 3 means 70 by 3 how much will come? Here observe 70 divided by 3. 3 1 ja, 3 2 ja. 10 will be there. 3 3 2 point 23 point 70 by 3 means 70 by 3 means 3 1 ja, 3 2 ja, 3 3 ja, 0.33 something. 23.3 is less than 24. No? So the given graph can have at most means maximum 23, but says 0.2 we won't take. Right? Graph G. 70 given in the question. 70, observe here, given in the question. 2 into 35. 70, no? Example 1. So which is the last possibility? Vertices in a graph 35 edges and all vertices of degree at least. Because sum of the, here we know that sum of the degree of vertices means 2 into 2e formula, that is 2 into 35 70. Directed graph. G U V comma E. V comma G V comma E. V comma E. The sum of the out degrees sum of out degrees out degrees of degrees of all the vertices is equal to of all the vertices is equal to sum of the degrees of vertices, sum of degrees of vertices degrees of vertices degrees of vertices in G in G, which is equal to the number of adjacent G, which is equal to which is equal to which is equal to number of adjacent G, number of adjacent G in G, number of adjacent G. That is small v belongs to capital V, sigma small v belongs to capital V to n degree of V, degree means degree of V, that equal to sigma small v equal to capital V n degree of V, that equal to mod E, that equal to proof. Proof. Since each edge has an initial vertex, since each each edge each edge has an initial vertex, has initial vertex, initial vertex, initial vertex, initial vertex, and a terminal vertex, and terminal and terminal vertex, and terminal vertex, and terminal vertex. The sum of the in degrees sum of degrees sum of degrees sum of degrees and the sum of out degrees sum of out degrees sum of out degrees sum of out degrees of all vertices in a directed graph of all vertices in a directed graph. In a directed graph. Directed graph. Directed graph. Directed graph are the same. The same. Same. Both of these sums are the both of these sums are the sums. Sums are the 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 number of edges in a graph. Number of edges in a graph. In a graph. Number of edges in a graph. Number of edges in a graph. An isolated vertex is one. An isolated isolated head. An isolated vertex. An isolated vertex. An isolated vertex is one. Is one. Which one? Which the degree and out degree are both equal to 0. Which the in degree and out degree both equal to 0. Equal to 0. Both equal to 0. Equal to 0. So in directed graph, a vertex V is called directed graph. Directed graph. Directed graph. A vertex V is vertex V is called vertex V is called pendant. 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 A vertex is called pendant vertex. Pendant vertex. If it is of degree 1, if it is degree 1, that means d of v plus d D of V, D star of V equal to 1. So it can seen that it can seen that the sum of integers of the vertices, the sum of integers of the vertices integers of the vertices integers of the vertices which is equal to 7, which is equal to 7 is equal to 7. The number of edges in that graph, the number of edges in that graph. In that graph. That graph. Hence proved. What we discussed the concepts. Number of edges, not degrees. The number of edges in that graphs, not degrees. Hence prove. What we discussed today. What we discussed today. Concepts. One theorem, two theorems, one example sum. Two theorems, 10 marks. Questions, example is 6 marks questions. Okay. Okay. Today I am leaving. We'll meet tomorrow on another chapter. I didn't understand what box Pina. The number of vertices with equal to 7, the number of edges in that graph is 7. Not box, that is star. D star V plus D star V equal to 1.
Hello. Hello, sir.
Hello.
Sir, paina in degree, out degree box lo unnai kada sir, vertex 2211402.
Ikkada madam.
Paina solution lo graph the 7.7 example undi kada sir.
7.7
figure.
7.7.
Figure. Out degree.
Theorem manam discuss chesindi 7.4.3. Page number 116.
పైన ఉంది ఆ సమ్ కాదు సార్, ఎగ్జాంపుల్ సమ్ అదే కదా?
కాదు, పేజ్ నంబర్ 116 లోకి వెళ్ళి 7.4.3 థీరం చూడండి.
ఆ థీరం ఉంది, కానీ దాంట్లో లాస్ట్ కి సమ్ ఆఫ్ ది ఇండిగ్రీస్ ఫిగర్ 7.7 లో ఉంది కదా సార్. సమ్ ఆఫ్ ది ఇండిగ్రీస్ ఇస్ ఈక్వల్ టు సమ్ ఆఫ్ ది అవుట్ డిగ్రీస్.
ఇట్ కెన్ బి సీన్ ఇన్ ఫిగర్ 7.7.
ఆ డిగ్రీస్ ఎలా సార్ వేస్తున్నారు?
ఏది ఇన్ డిగ్రీస్ అవుట్ డిగ్రీస్?
ఇన్ డిగ్రీ నెంబర్స్ 2211402.
Find the in degree and out degrees of each vertex in directed graph. The in degrees is 2, 2 2 1 ఏబిసిడి ఏలో ఇన్ డిగ్రీ 2 వచ్చింది.
ఎలా సార్?
ఇది ఎట్లా వచ్చిందంటే లూప్ ఉన్నది కదా, ఏ నుండి కిందకి లూప్ వచ్చింది చూడండి,
సార్
కరాస్ ఇన్ డిగ్రీ, అవుట్ డిగ్రీలో ఏం లేదు మళ్ళా, అందుకోసం 1 అని పెట్టుకున్నాడు. నెక్స్ట్ బి బి దగ్గర చూడండి, బి 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 దగ్గర ఎన్ని వచ్చినాయి చూడండి, 2 ఇన్ డిగ్రీస్, అవుట్ డిగ్రీస్ వచ్చేసి 4, అంటే 4 వర్టిసెస్ టచ్ అవుతున్నాయి.
సార్ ఒకసారి డయాగ్రామ్ వేసి మీరు ఎక్స్ప్లెయిన్ చేయరా, అర్థం అవ్వట్లేదు.
రేపు ఎక్స్ప్లెయిన్ చేస్తారు, ఎందుకంటే టైం అయిపోయింది, వాళ్ళు కట్
సరే.
చేసేస్తారు, సగం డయాగ్రామ్ పోతుంది. ఓకే,
సరే
ఇన్ డిగ్రీ అవుట్ డిగ్రీ రేపు మార్నింగ్ 7 o'clock ఎక్స్ప్లెయిన్ చేసి నెక్స్ట్ యూనిట్ స్టార్ట్ చేస్తా. ఓకేనా?
సరే సార్, థ్యాంక్ యూ.
బాయ్.
ఆటోమేటిక్ క్లోజ్ అయిపోతుంది.